Back. Suppose that f from A to B is a one-to-one correspondence. Define F inverse from B to A. Explain in details the composition FOF inverse and F inverse OF. Alright, so here I have started a picture. You have set A, set B. You have many elements in A. Okay, I have pointed out just one, that's little a. Likewise, there are many elements in B possibly, and I have highlighted just one of those. Okay, how do you define F inverse? You see, F inverse okay, is a function from B to A defined by, right? How is it defined? You say F inverse of B is A if and only if, okay, if and only if f of A equals B. So you have element B here. You see it, look for its pre-image. There should be a unique pre-image of B because F is one-to-one correspondence. So that unique pre-image is what you assign B to. Okay. Now let's look at F O F inverse, right? So F inverse is from B to A. So for any B on the right hand side, what are you doing? First, applying F inverse of B, F inverse of B, right? That's what this is. Now what is this? F inverse of B is a pre-image A. Well, what is F of A? Well, A is a pre-image of B, so F of A is B. You see? So what does that say? F O F inverse is actually identity map on B, because for every B of capital B, I get little b back, right? So this is for all B in the set B. Okay. Likewise, let's look at F inverse O F. F inverse O F. So first F, then F inverse. So first F, then F inverse. So first F means you start on an element A. So F of A, let's see, F inverse of F of A. Well, F of A is some element B. Okay. Well, if F of A is B, then F inverse of B is A, because that's what definition of F inverse is. And this is the case for all A in the set A. Therefore, F inverse OF is identity function on A. All right. Now graphs of functions. Let F be a function from the set A to the set B. The graph of a function F is the set of ordered pairs A, B, where FB equals, FA equals B. So you see how usually we write Y equals Fx. That's all I have said. B equals FA. Okay. So ordered pairs where the second coordinate is F of the first coordinate. Let F be a function from the set of integers to the set of integers be given by fx equals 2x minus 1. What is its graph? How do you visualize this graph? Well, the graph of f from z to z is given by f of x equals 2x minus 1. All right. So you want to, the graph of f is the set of ordered pairs A, B such that f of A equals B. What does that even mean, right? That's the graph definition. So this is equals AB such that, let's look at where A comes from. A comes from integers, right? And B is f of A. F of A is 2A minus 1 is B. Aha, this looks like a linear equation. But am I looking at all the points on my line? No. Let's look at how do we visualize a linear equation, right? So the linear equation is 2x minus 1. That's the linear equation. That's the line I'm looking at, right? So this line consists of every point on the real number. I don't want every point. I want just integer points. So when x is 0, when a is 0, b is negative 1. When a is 1, b is 1. When a is 2, b is 3. I hope you understand. I'm plugging in the values. When a is 3, b is 5. Something like this. So all you're going to get are separated points. They are called discrete points. So you don't get the entire line, but you only get points where a is an integer and therefore b is an integer. All right. Now let f be from a real number, set of real numbers to the set of real numbers. What does its graph look like? Well, the graph of when x is allowed to be every real number, graph is this line, every point here, okay, uncountably many. Whereas when my set is allowed to be only integers, then I get only separated points, discrete points when x coordinate is allowed to be integer. All right. So similarly, you might want to think about the graph of x squared minus 1. Okay? You think about this. Next, the floor function. The floor function assigns to the real number x the largest integer that is less than or equal to x. The floor function of x is denoted by floor x. How do you visualize the floor function, right? So let's write this down. F is from set of real numbers to set of integers. How is it defined? F of x equals floor of x. Okay, floor of x is what? The greatest integer less than x. Okay, so let's look at this as an example. Less than or equal, I'm sorry. Okay, so f of 1, Well, what is the greatest integer less than or equal 1? It's 1. F of 0 is 0. F of 2 is 2. F of negative 1 is negative 1. F of negative 2 is negative 2. Does that mean I'm always going to get the same input as output? No. What is f of 1.5? Aha, now let's think. Is 1.5 an integer? No, it is not. So you're looking for the greatest integer less than or equal to 1.5. Since 1.5 is not an integer, you're looking for the greatest integer less than 1.5. There you go. 2.3. Same thing. 2.3 is not an integer. So the greatest integer less than 2.3 is 2. F of 0.9. Greatest integer less than 0.9 is 0. F of negative 1.2. Greatest integer less than negative 1.2 is negative 2, and so on. So the answer is always an integer, but your input can be any real number. So how do we visualize this? So let me draw a picture, right? Let's have our axis here. Okay, somewhere here, right? So I have my numbers here. So that's 1, say pretend that's 2, 3, 4, negative 1, negative 2, negative 3, negative 4, and so on. Okay, it goes on forever. 1, 2, 3, negative 1, negative 2, negative 3. Okay, so let me write down the text for each one. That's 1, that's 2, that's 3, that's 4, negative 1, negative 2, negative 3, negative 4, and so on. All right. I could identify these also, but you have an idea. So what's happening here? When your input x is here, say 0.5, was the greatest integer less than 0.5? Its height is 0. So all these guys get height 0 except at 1. At 1, well, 1 is an integer. So greatest integer less than or equal to 1 is 1. So at 1, I get height 1. Say 1.7. What's the greatest integer less equals 1.7? It is 1. So all these numbers get height 1 except when you go to 2. Greatest integer less equals 2 is 2. And 3. Whoops. Whoops. I made a mistake. This is a filled in point at 3 and open here. Likewise, on the negative side, negative 0.5. What is the greatest integer less equals that number? Negative 1. So I get height negative 1 here and 0 here. Negative 2 here and nothing here. negative 3 here and